welcome to this video where we are dealing with integration. So for the purposes of further studies in mathematics, we have this concept of integration as part of calculus, but we have two types of integrals. We've got what we call the definite integral and what we call the indefinite integral. So what the definite integral actually represents is the area under a curve. So as you can see with the example shown here, you've got the function f of x, and you've got a boundary, a lower boundary of a and an upper boundary of b. And if you take the integral of f of x and between a and b, what you get is the area under that curve. So whenever we have to apply our boundaries, the upper and the lower boundary, we get the area. So this is called the definite integral. And you can similarly see if I've got the function of x squared and my domain is between 0 and 1, so I can find exactly what the area under a curve. So this blue area here shaped in like called S is the one that is the area under that particular curve. So we find that as the definite integral. So the sign for integral is basically a sign that looks like that. You can write it in whatever form, and then you can write your expression, and it always comes with the dx or the d of the variable that you are integrating with respect to. So this is dx, so it is the integral with respect to x. So therefore, in the further studies mathematics, you then have the formula given to you on how to integrate. So you have your integral sign, you have your lower boundary a, you have your upper boundary b of x of n dx, and then when you integrate it, you more or less do the opposite of what you normally do with derivatives, in that you'll add 1 and then you'll add 1 to the denominator, and in the case of the definite integral, you then have to apply your boundary. So you'll have to sub in b into the equation and then minus the sub in a, and then you're able to do that. So we start dealing first with the standard types of questions. The standard types are the ones that normally you do in core mathematics. And just like when you're dealing with differentiation, what you then do, you need to get it into a form which is differentiable, and then you can work it out from there. So don't worry about that. We will do lots of questions based on this. So let's start with the very first question. So here, as you can see, I've got the expression integral of this cubic function. And what we're going to do is find what the general expression is for the area under the curve. So according to our rules of integration, this is exactly what we'll do. So this will become x to the 4 over 4. Plus, you keep the constant as it is. This is x to the 3 over 3 minus, now you increase the exponent because there is a 1 there, so you increase it by 2 and divide by 2. Plus, if you have a constant, this is same as saying 5 to the 0, and therefore you can increase that expression. So that becomes 5 to the x, and you always have to add your constant of integration, which is the value for c there. So what you then do from there is try and simplify this expression for yourself. So when you're simplifying this, this becomes x to the 4 over 4. The 3's cancel out. You now have x to the 3 minus x squared over 2 plus 5x plus c. So in many ways, this will then give you the integral of this expression, and then you'd be all done with this. So that is the integral. But now I want us to deal with the more definite integral. So the definite integral is when you are applying your boundaries. Very important that you know that. So I'll rewrite the same expression again. And now we will apply our boundaries. And we can get to see what that looks like. So we'll go plus c, and then you write the expression, you have your upper boundary there and your lower boundary there. And the way we do this is that with our upper boundary, we then go in and substitute the whole number as it is. So this becomes 2 to the 4 over 4 plus 2 to the 3 minus 2 to the 2 over 2 plus 5 to the 2 plus c. And then you are minusing that with the same expression, except now you're subbing in 0. Plus 2 to the 3 minus 2 to the 2 over 2. 0, 0, 0. And then you have plus c over there. And I think this is quite chilled now. You are able to see what's happening with the expression. So what you'll then do, you can clearly see that this other side will just be 0. And if you plug this into your calculator, you can use a physical calculator there on the side, but you'll get that this gives you 20. So what does this mean? So this means that the area under a curve of this cubic function, whatever it looks like, let's say it's a cubic function that looks like this. If you're bounding it between 0 and 2, that shaded region between the x-axis will just be 20 units squared because it is area. So that's how you'll be able to do an expression of this particular type, which I think is quite nice. So let's just do one more example just to solidify our understanding of this. So a reminder again, if you've got a question like this, it is not in its differentiable form at the moment or its integration form. So we want to write it as explicitly as we can. So this becomes 2, or the integral of 2 over 3 minus 4x to the minus 2 dx. So now this is in a nice form that we can integrate, So because this is in a nice form that we can integrate, we can now find the integral of this. So remember, I'll add 1 to that. If I add 1 to that, I get x to the 5 over 3 divided by that whole expression, 5 over 3. We'll simplify this in the next line. So this becomes x minus 1, and then you have minus 1 over there, plus the constant of integration, which is c. Which is quite cool. Just a reminder on the previous question, plus c and minus c will cancel out. That's why we don't see it again there. So in simplifying this, the 3 does come over there. So this is 5 over 3 over 5. Negative times negative give us the positive x to the minus 1 plus c. So as you can clearly see, this will then be our definite integral. And therefore, we are allowed to get to the point where we can work with the side. So we will now apply our boundary. Let's use a different color so we can separate these questions. So this will become 3. The way we'll do it, I'll just rewrite that over 5 plus 4x to the negative 1 plus c. And then we'll apply our upper and lower boundaries. So there they are. So what does this mean? This means this will be 3, you substitute 4 to the 5 over 3 over 5 plus, would go 4, substitute 4 to the minus 1, that'll be it, plus c, the c's will cancel out, and then you've got 3 to the 1, 5 over 3 over 5, plus 4 times 1 to the negative 1 plus c. And if we perform a subtraction of all of that in your calculator, work it out quickly. And I think if you do work it out, you'll be able to get an answer that gives you, I think, 2,45 units. Okay, so this is just a good video now explaining how to do basic or standard forms of integration and how we apply the definite integral. So what I'll be doing in the next video is going more into doing other examples of these basic types in the next video. So please look out for that.